This video is for section 7.1, rational expressions and functions, and today we're going to look at multiplying and dividing, and then in the next video we'll take a look at addition and subtraction. And just like with fractions you learn in middle school, multiplying and dividing is actually an easier task than adding and subtracting, and we'll look at some of the reasons why in this video. And we're going to go through 3 examples, and they're all there on the sheet that you have in front of you, so feel free to pause this video at any point if you want to try to move ahead, or if you need to stop and kind of go back to steps if you need to. So here's our first question, and it looks like we have 2 rational expressions here, some x's, some y's, some coefficients. And just keep in mind that everything that we're going to do in this section basically hinges on the rule that we looked at in class, where a over b is equal to a plus c over b plus c. That's the theorem we have in notes in class, and just all it means is that we usually start with something that's kind of messy here, and if we identify the common factors, we know that we can cancel them out and we get something that's simpler to look at. And that's basically the idea for this whole video and for these problems. So if your factoring skills are sharp, if you're able to cancel things efficiently, you'll be in good shape here. The only piece where this gets a little bit tricky, and my best piece of advice is, when you cancel things, leave a lot of room and make sure that you make it clear what survives after you cross things out. I sometimes get students who start crossing things out and then all of a sudden you can't see what's left. So let's look at what we have here. I see some coefficients, some x's and some y's. Let's start with the coefficients. I see a 9 and a 27. I can cancel those. I'm left with a 1 and a 3. I see 4 and 6. I can divide those both by 2. Leaves me 2 and 3. Now the x's and the y's, you can do this a couple different ways. You can do it in stages. Here's how I prefer to look at it. If I look in a numerator, I have x to the 4th and I have x. So altogether, I have x to the 5th in the numerator. And in the denominator, I have an x and another x to the 1st. Multiplied, it leaves me x squared. And I know that when I cancel those and I use the law of exponents, that will leave me with x cubed, and it's in the numerator because I have a higher power of x in the numerator than in the denominator. So I will have x cubed in the numerator when all is said and done. Powers of y, same deal. I have y hanging out here. And I also have y squared and y cubed here in the denominator. That's y to the 5th. I know that when I'm done, that will be 1 over y to the 4th. So therefore, I will have y to the 4th left in the denominator. And you can already see how messy this problem is getting. But if you're systematic about it and you create your own little system for making sure you know what's left, you'll be in good shape. So what do I have left here? Well, I look and I see that for my numerator, I have 2 and I have x cubed, and everything else canceled. So I have 2x cubed left in the numerator. And the denominator, I have a 3 and I have a 3, and everything's being multiplied. And y to the 4th is coming along for the ride too. So I have 9y to the 4th. So that's it. So everything is canceled, and it is simplified. Here's our second problem. Looks a little bit crazier. Now, the one thing I want to point out is I think your worksheet might have a misprint. Look at where I'm circling here. That needs to be a -5. If it's not, then that numerator is not going to factor the nice way we want it to. So make sure you make that change. But basically the idea here is we want to factor everything. What we can't do is we can't just say, hey, here's a p and here's a p, let's cross them out. And the reason we can't do that is because it goes back to this rule again, is that we can only cancel common factors. And that p here and here, those are things that are being added. So we can only cancel factors. So be careful and look out for those traps. My suggestion to you is that you take a lot of space in your paper. Don't be shy about it. Write yourself some fraction bars. We're going to factor everything that can be factored, and then we'll look for common factors that cancel. So my top left, my numerator here, I see that that factors fairly easily. I have p minus 5, p plus 1. P cubed, can't do much with there. That just comes along for the ride. The top right, my numerator, it has a GCF. I can take out a p, and I am left with p plus 3. And a GCF also on the bottom here, I have a 2. And that leaves me p minus 5. Okay? So now I'm looking for things that can cancel. It'd be very cruel if I gave you a problem where things didn't cancel in some way, shape, or form. And they do here. P minus 5, very nice. And also p and p cubed. That will leave p squared in the denominator. So now this problem simplifies as p plus 1, p plus 3, over 2p squared. And that's it. So now I have one fraction instead of 2. You can go the next step and go ahead and multiply it out and make it look prettier. That's not really the main event of what we're doing here, but that's okay. P squared plus 4p plus 3 over 2p squared. No big whoop. That looks nice. Okay, last problem. Last problem is a division problem. And the idea with division, it's no different than fractions you learned in middle school. If we need to do A divided by B, the rule is that that is the same as A times the reciprocal of B. So basically that second fraction we're going to take the reciprocal of. And what I suggest you do is we're going to knock this out in one step. We're going to factor the numerator and the denominator in that second rational expression, and we'll flip it at the same time. So here's what I mean. We're going to rewrite two fraction bars, put a multiply sign in between them. We're going to hope that a lot of stuff cancels here, or a lot of stuff factors here, and it does. The top numerator on the left is x plus 3, x plus 3. This guy right here, we got to think ahead a little bit. It actually does two things. It has a GCF of x, and you'll also notice that when you take that GCF out, you have a difference of squares. So that actually is x, x plus 5, x minus 5. So two different factoring techniques going on there. Now what I'm going to do here is x squared minus 9 I know is x plus 3, x minus 3, but since it's division, I'm going to move that to the denominator, and I have the multiply sign in between. So I've taken care of that with the multiply sign. And then I hope that this denominator here factors as well, and it does. X minus 5, x plus 2. So everything factors. And now we're just looking for stuff to cancel. It gets kind of messy here. I see x plus 3, x plus 3. I see x minus 5, x minus 5. And it looks like that's it. So we'll rewrite it all as one fraction now. I have x plus 3 times x plus 2 in the numerator. And then in the denominator, I have x, x plus 5, x minus 3. And again, sure, we can multiply it out to make it look like polynomial over polynomial. I have x squared plus 5x plus 6. And then two things here. I will multiply these guys, and then I'll multiply by the x. I will end up with x cubed plus 2x squared minus 15x. So if your factoring skills are sharp, this should be a fairly easy section for you, and you'll have a couple problems to do to reinforce that.